right, so next presentation is on beyond emissions, navigating noise for heat pump integration. And as I've read on your sweaters, you're about to make the future better if you turn around right. So because you love the future, for those who are not familiar with German, and yeah, so we're looking forward to your talk. Thank you.
Thanks for the warm welcome. I'm happy to be here with my colleague Daniel today. My name is Mirjam. We both work for Gerigk, which is a German startup founded or part of Westenergie. Westenergie is a German distribution system provider, no operator. So those are the people who build the local infrastructure that bring heat and energy to your home. So just to give you a little bit of context, what Gerigk actually does. So we developed a digital twin for the German heat supply at the building level. So that means we take various data like consumption data, infrastructure data, but also real data that is being provided by our customers and condense that to a building data product. So this data product is very central to any development that we do. For example, we are producing scenarios, for example, about the technology transition pathways or potential technology transition pathways to become climate neutral. But we also have models such as consumer behavior. So when does a consumer change from one heating technology to another? Or whether they decide to refurbish their building actually to consume less energy. And with all of those results, we bring that into our product, which is the DigiPad, and visualize that to our customers so that they, in the end, can make better decisions to become climate neutral. So that's the overall goal, and that's why we love the future. And currently, as the previous slide might already imply, our current focus lies with the heating sector. So to those people who are a bit unfamiliar with the energy sector is generally being split up into three sectors. One is electricity, the other one transportation, and then there's the heating sector. And in the year 2020, actually this huge heating sector was responsible for 40% of German greenhouse gas emissions. And unfortunately, in recent years, and with recent years, I mean the past 10 years roughly, those greenhouse gas emissions, or the CO2 equivalent in megatons, that sort of stagnated. So the emissions did not go down anymore. So the German governance has a particular interest to bring down that curve. And in order to do so, or to achieve that, they recently passed a law that forces or incentivizes roughly 11,000 municipalities in Germany to come up with the heating concept for their municipality. And the heating concept is nothing else but a plan how to become climate neutral in the heating sector to reach German climate protection goals. And one very promising technology in order to achieve that are actually heat pumps. So just a heads up, I'm not a technology expert on heat pumps, but what you can see on the diagram is an air source heat pump. They roughly work like a refrigerator, but the other way around. So you have your refrigerant that is in the cycle. It's being compressed by a compressor using electrical energy. And by the compression, the refrigerant gets heated up. So it's being pumped to a higher temperature level. Then it releases that energy into your home, and then the whole cycle begins again. So under the assumption that the electricity that you use to operate that compressor, using a heat pump is actually a climate neutral heating technology. And that is why it's being very, very interesting to our customers to understand how they may use heat pumps to become climate neutral. But, well, it sounds grand, but there's a twist. So on the left-hand side, you can see the relation between the noise that a heat pump emits and the maximal power that a heat pump can provide. And roughly speaking, the louder your heat pump, the more power it can produce. And of course, there is a German law how noisy a heat pump may be, and it depends on the type of settlement structure that your home is built in. So that you can see in the upper limits you can see in the table in the middle column. And just to give you a better understanding what 80 decibels actually are. So 80 decibels or 85 decibels, that is roughly your vacuum cleaner that you use at home. Then when you go down to 60 decibels, that's your refrigerator. And then when you whisper, that's roughly 20 to 30 decibels, roughly.
With the microphone, it's louder.
Yeah, with the yeah. Imagine me whispering. So that was the x-axis of that curve. Now when it comes to the y-axis, so an average home roughly consumes needs 1 kilowatt to be comfortably heated. So we are actually often in the very bottom of that curve. But it still becomes, or it may become, a limiting factor, particularly in dense settlement structures. These noise limits become the limiting factor, particularly in dense settlement structures. So in the context of this talk, while there might be various questions that a mayor in a municipality may ask to derive the heating concept, we're just going to focus on this one, whether heat pumps actually play a significant role in the transformation of a municipality's heating sector. And to answer this question, or we try to answer this question in 3 steps. So I'm going to briefly talk about deriving noise limits for a particular building, or noise limits for the heating pump that a building may use. And then I'm going to hand over to Daniel, and he is going to present a heuristic algorithm that tries to maximize the power a heat pump may provide for a home. And then we bring it all back in the 3rd part of the talk to the heating concept of a municipality. So we go away from the building and look at it at a higher level. So let's jump right in. So I'm not going to spend so much time on the first part because our approach here is really simple. So we use a land use to derive the noise limits. We need to identify the type of settlement structure of a home. And in order to do so, our mayor information is the land use information that we get from OpenStreetMap. So the map that you can see on the left-hand side, that's actually Munich, that's the city where I live, and the different colors are the different types of land use that you might encounter provided by OpenStreetMap. So the red is urban, the green is forest, blue is water, and then purple is commercial. And then to map a building to a type of land use, now we zoom in to the building, to the map on the right-hand side. There is the Marienplatz, a central place in Munich. And most of it is urban, but you can see in the bottom left corner also some purple. Those are the commercial buildings in that area. And then if we were to assign a land use type to Munich's toy museum, which is the white square that you can see, then we would just use the land use that is closest to that building. In this case, it's really obvious because there's actually overlay between the toy museum and this urban land use geometry. But note that the land use information of OpenStreetMap is actually, it doesn't cover 100%, so there are gaps in between. So we sometimes assign a building to its closest land use provided by OpenStreetMap, but we have an upper bound and say if it's further away than 5 kilometers, then we can't assign a land use type. So now that we have the land use, we then combine that information with other data that we also have. For example, the place that is also provided by OpenStreetMap, and the location, which comes from a different data set. And then we just have a lookup table. So it becomes really simple. For example, if the land use is residential, you are in a city, and you are central, then we assume that the settlement structure type is urban. And then if we go further outwards, so if it's residential city, but you are in the periphery, then we say it's probably more residential than urban. And then based on the settlement structure types, we now, because of the law, know the noise limits that are being put in place for the heat pump. Note that these columns in the spatial information, they aren't always filled because we don't always use all of these features to create a mapping. For example, when it comes to commercial and industrial, this is a type of land use that directly maps to the commercial and industrial settlement structure type, so we don't use any other features like place and location. So that is very basic, but it provides us with the noise limits for every individual building that we have in our building data product. And that brings me to the end of my section, and I hand over to Daniel.
Thank you. Yeah, so I'm Daniel, data scientist and data engineer at Digico. Happy to be here. Yeah, so this is about heat pumps, especially about air source heat pumps. So as an icebreaker, I would like to ask who of you have been actually involved either in only in the planning or really in the installation of a heat pump in any form, or you know something about heat pumps from other sources, other reasons? Nobody? Yeah, okay. Some. Yeah, some. Okay, I see some. Yeah, so Digico and in general, the future goal definitely would be to have more heat pumps in Germany, but yeah, let's see how that works. So I'm going to talk about a problem, about the special problem of where to put the heat pump exactly, the air source heat pump. So in my opinion, it's a really fascinating technology because literally it produces heat out of thin air, more or less. So you have a certain heat demand for your building, and it's possible to satisfy that heat demand just by a heat pump. But the problem, as Mirjam said, is that the more powerful your heat pump is, the more noise it produces, and there are regulations that don't allow you to produce too much noise, so you have to make sure your neighbor doesn't get disturbed by the noise you produce. So you have to think about where to put your heat pump. Of course, this is not advice for anybody where to put their heat pump really in reality, and if you actually have a home and want to put your heat pump somewhere, you should take into account more aspects, of course. But I will later say something about the motivation for Digico to consider this problem. So let me start here. Survey, okay, we did that already. Yeah, so let's say we have a building, a random building. It has a certain shape. So usually, of course, the shape is just a square, but so this is a bit more complicated. Okay, let's go on. So the building is surrounded by neighbors. Of course, you can vary the distance, the maximum distance you consider when speaking about neighbors. So, but for the question of where to put your heat pump, it's fine to have, for example, this distance around the building. So, and the question we pose ourselves is, what is the optimal position for the heat pump? Near the center of the building. We don't want to put it anywhere. So that the distance to the nearest visible neighbor, so visible is important, is as large as possible. So the larger this distance is, of course, the more power you can make your heat pump produce. So we have a couple of obstructions or restrictions that we came up with. So the first one is that the heat pump shouldn't be too far away from the building. Of course, it's possible to have the heat pump like 15 meters away from your building, but then you get problems, or then you have to transport the heat from the heat pump to your building, and you always lose some some amount of energy during the transportation. So the closer to the building, the better in general, but it should, oh, I switched, okay, it should not be too far, but now I say something about bullet point 1. So it should also not be too close, because actually I'm not 100% sure, but I think if it's too close, I mean, it can produce vibrations in your home if it's perhaps directly at the wall, and also the noise it produces would in some way affect your own building. Also, the noise is in general not transmitted in every direction, but normally it's directed more or less. So it's moving in some kind of cone in one direction. So the next restriction is that it's not actually in a corner of your building. So this building that is here has several corners, and we don't want to put the heat pump directly in the corner because of what is called resonance effects or something. So so the noise waves, the sound waves would somehow multiply themselves, and you would get problems. I don't have a picture for that, but so one approach would be just to consider the convex hull of the building, but then perhaps you would cut off too much. Could also just cut off the corner when you later consider places to put your heat pump. So yeah, also this is another minor restriction. So if you have a tree, you don't want your heat pump to be too close to the tree. In general, it's not a disadvantage to have bushes and trees around your heat pump, because they also absorb some of the noise. So, but you don't want to put it too close to a tree. And so this is the most important restriction in terms of the approach. So yeah, so we don't want it to be too close to any of your neighbors, but so the specialty is only visible neighbors are considered, because if you put your heat pump somewhere and your neighbor is behind your own building, then the sound waves. So we assume that sound waves move like light rays. So if it's behind the building, they won't be affected by the noise. So this is the question again. So what first comes to mind would be Voronoi diagram. So of course, Voronoi diagram would tell you for each position which neighbor building would be the nearest one. So you could use that in some way in your algorithm, but directly there are two problems. So two difficulties. So first, the building A. Okay, I didn't say. So A is the building, your own building, the building in the middle, in the center. So we don't plan to maximize the distance to your own building. So quite the opposite. We want to be not too far away from your own building. So if you apply Voronoi diagrams, it will often tell you, okay, the nearest building is your own building, but that won't help you. You want to know what is the nearest neighbor building. And so then you would say, okay, we just remove the center building and do a Voronoi diagram then. But that would also be problematic, because when you want to see whether your neighbor building is visible or not, you have to consider also the building A in the center. In fact, it's the only building you have to consider for this problem, because I will show a picture in a second. Oh, yeah. So the approach, the simple approach we took. So I'm sorry, this is another building, but still should be in principle should be clear. So we have the approach we took is we identified candidate points for our heat pump around the building. So I think it's 1 meter, distance of 1 meter. Perhaps it was 3, I'm not sure, 1 or 3. you can of course vary it, and the closer the distance, the more candidate points you have, and of course the longer your algorithm needs to run. And then yeah, we calculate for each neighbor building the distance to the neighbor building. To make the algorithm run a bit faster, we don't consider the whole building, the whole neighbor building, but only the center point of the neighbor building, and calculate the distance to that center point. But for example, here in this image, you can directly see that this neighbor building below is not visible from the candidate point there, because yeah, the building is in the way. So yeah, so here I have a couple of example outputs of this algorithm. So yeah, I mean, it speaks for itself. So this is a good position for your heat pump. Here's another one. Another one. I think the circle is a tree, for example. Another one. So what's the impact? Yeah, so Mirjam already spoke about the Wärme report, the heat report at DigiCo. That's one product that we sell. So it's yeah, it contains information about all the buildings in your city. First for the status quo year, 2024, and then there are projections into the future, like 2030, 35, 40, 45. And for each year, the model, like, I wouldn't say determines, of course, because it's a projection, but it makes plausible simulations about what kind of heating technology the building will have in that future moment. Like, will it change the heating? Will it keep the old heating? There are many like restrictions, for example, starting in 2030, I'm not sure, but at some point you are not allowed to install further oil heatings in your home. And so all those restrictions are included in the model. So this is a teaser for tomorrow mostly. So tomorrow, Michael, also from DigiCo, will talk about the Wärme report in more depth. Yeah, so if we want to decide, for example, in the year 2040, whether a building that at that time has an oil heating, let's put it differently, it has an oil heating, and we want to know, is it possible for the building to change to a heat pump technology? And so for that, we must know whether the heat pump is able to cover the heat demand of the building. And for that, we need the answer to this question, where to put the heat pump, because so in this model, the single factor that decides how powerful your heat pump can be is just how far it is from your neighbors. So if it's not possible to place it in a good way, so if you're in the middle of the city and have too many neighbor buildings, you're not able to put a powerful heat pump and use it to cover your heat demand. So this is an image of the heat report. In German, it's Wärmekarte or Wärme report. I mean, we have several names for it. It shows the distribution of the heating technologies within, I think, the city of Essen. Yeah, okay, it's Essen. Yeah, so DigiCo is based in Essen, so makes sense. Yeah, so you can see there's not too much. I don't know if you can see it. The colors and points are very small, but there's not a lot of heat pumps. In fact, I can't even see any from the image. But let's try to change that in the future. And so we are a group of 6 people from DigiCo here, and we're happy to discuss any topic, especially this algorithm or any other topic. So we're happy if you approach us. Thank you. Yep. Do you have questions? Oh. Yeah, please. there's a question.
Thank you very much. Questions? Yes.
I have a question. Does your algorithm take into consideration that there will be another building built in the future, so the actual heat pump location that you suggest is not available anymore in 5 years?
That would be really cool to incorporate that, yes. But no, it's not. It's not taking that into account. For that, you would have to know like the plans. Okay, if we have those sources, I think we could incorporate that, but it's not planned.
So it's more question of missing data than technology, right?
Right. Yeah. And I also think, okay, can you rely on that? If some source tells you there will be a building, but then suddenly they decide, okay, they don't build it. I'm not sure.
So we update this building data set on a regular basis to incorporate changes in the settlement structure. But we don't project into the future expecting like new settlements in the area.
Excuse me, stop. Because we have people who are online listening, it will be difficult or not possible for them to listen to the question without the microphone.
We can discuss later.
Yep. There's another question here.
Sorry, I might not be as interesting. Have you commercialized this yet? And do you see it as a macro tool for the whole area or individual homeowners?
No, exactly. So for individual homeowners, I think there would be many more factors they would have to take into account. So I think it's not suitable for individual homeowners. But at Digico, I'm not totally sure about the situation right now, but in general, you can, as a customer, as a client, you can purchase this, or you can, I'm not sure if it's planned to include it by default, or if it's an additional option you have to purchase, but yeah.
Maybe I can add to that. So as I mentioned in the beginning, this is a heuristic. So if you actually wanted to have the optimal solution for your heat pump at home, you would also have to consider like the boundaries of your property, the streets, and all of these things. And to like reduce the complexity of the algorithm, we made the very conscious decision to not consider this because we are more interested in getting this map. Because for a municipality in general, it's more interesting to know whether heat pumps actually play a significant role in my heat concept. Yeah. So we are not focusing on the individual home, we are focusing on a report like you can see on the slide.
But just one small note, so the streets are excluded as candidate points, so at least that's...
There were various variants. Yeah. We have various variants for the algorithm. Sometimes they're included, sometimes not.
Okay, thank you. One final question, just to make sure that people can switch. So I would like to keep the time slots. Yeah, that's fine.
Thanks, Antonio. What's the open geodata situation in Germany? It seems a bit difficult to have to use open user-provided data to do the zoning information, for example.
Yeah, so I mean, OpenStreetMap in general, for example, is great, but also, yeah, we have many data sources. The most difficulties we have is, for example, with street names and house numbers particularly. For example, if we get data from clients about gas consumptions, or so this WEMR report is based on just per default just on statistical data, but the clients have the option to give us real data, for example, gas consumption or anything else. But then they give us street names and house numbers, but often we struggle to map to join it with our data, yeah. And we don't find the addresses sometimes.
Don't you get access? I mean, from a political point of view, what you do is totally in sync with what Germany is after, right? So wouldn't you have access to the necessary data, let's say census or whatever there is,
Yeah, so there are open data sets. We have Statistikbüro. So we have like general statistics for the whole of Germany, but then all federal states have open databases that you can access.
Okay.
That is data that we may use, but then there's the challenge to integrate all of that. And of course, we get, as Daniel already mentioned, we do get more accurate information from our customers at the local level.
Okay. But it's, I assume, still the old pain that we all have, matching data, et cetera, et cetera.
Yeah, so that the data exists, but we have to like integrate it into our model.
Okay. Yeah. Well, thank you very much again. And
if you guys want to reach out, that's us.
Yep, we'll keep the slide on. And I think in the meantime, people are switching rooms and swapping. If you still want to go to the other room and on the upstairs floors, that I think that's fine. Otherwise, I invite the next presenter,